without further delay, let's start with chapter 7, reading. This is the last chapter before we serve our model on different platforms, and it's certainly an important chapter as well. So let's spend, I would say, spend a good 50 minutes to read this. And I would, this is a lot of reading, but I would skip some of the fairness, some of the content on fairness indicators, because not all of us, deal with fairness.
Speak for yourself.
Fairness indicators in, unless you're dealing with models that deal with some sort of opportunities, loans, and credit card approvals, data that has human related data in it, right? So otherwise you probably are not dealing with that. So if you want to skip that, feel free to do that. Yeah, so all right, so Mash, if you don't mind putting the timer up.
It's already up.
Thank you. And we'll regroup in 50 minutes.
gentlemen, reading's over.
All right. Cool. How you guys doing? Are you guys almost done or finished reading?
Yep.
Yep.
Cool. Cool. All right. So I want to just ask quickly, were you guys able to run through the pipeline, at least train the model previously? Is everyone okay with that?
Nope. I had some issues with CUDA update that I'm trying to do on my local machine. So I was previously using 10.1. I am updating it to 11.x, and be it 0 or 1. So, but I'm having some issues in dealing with the couple of cards that I have. So it's uh, currently unable to work. I will fix it, but yeah, currently I have uh, uh, issues on my local machine, so I haven't been able to uh, uh, run it now. So
Yeah. Yeah, I hear you. I'm having a little trouble with the evaluator. It seems like there is an error, but I'm seeing the errors from the same errors from the Google tutorial, TensorFlow tutorial as well. So I don't know if that had an impact. And I haven't been able to push the model or push the blessed model to the directory yet, because I've only been getting the non-blessed ones for some reasons, and I'm still trying to debug that. But hopefully you have been able to run through the training at least. So and run through every single step right before, right to this step. And I'm testing, the model resolvers and stuff. And it seems like this is, so with TFX 0.30, the code is already changing from resolver node to tfx.dsl.resolver. And yeah, so this is the component that I'm having a little bit trouble with. But anyway, let me start with the chapter. I think this chapter is relatively straightforward. Basically, we're just analyzing the model, and if you guys, and this is again, the last step right before the model deployment, which we will basically deploy a model to the AI platform, or maybe Vertex platform, since it just rolled out. But this book still just covers AI platform instead of Vertex platform, obviously. And primarily we're kind of using TensorFlow model analysis, Tfma, as the library or package within the TensorFlow ecosystem to do the model analysis. And there are tools like fairness indicators and what if tools for this as well. I'm not going to spend too much time on this. This is pretty basic. Excuse me. There's pretty basic classification stuff. Okay. Basically, the metrics: true positive, false positive, true negatives, false negatives, and the confusion matrix. the accuracy, precision, recall. This is all pretty fairly basic ML 101 stuff. If you're not familiar with this, I would encourage you to read the, I believe the chapter 3 of Hands-on ML, if I'm not incorrect, or chapter 4. There should be a classification chapter at the beginning of the book. And there's some regression metrics that the book briefly covered here. Again, fairly basic stuff. Not going to spend too much time on that. Okay, so TensorFlow model analysis. You can install the package separately with pip install TensorFlow model analysis right here. And you could you can convert the saved model to eval shared model with tfma.default eval shared model. Okay, and here's how you configure the evaluation or evaluator, and you could well, you need to tell the evaluator that your label key is consumer disputed. In our case, that's the target variable. And you can specify different metrics for the evaluator to evaluate. Okay. And you could also analyze TF Lite models in TFMA. So not just TF models, you could do TF Lite as well. Then you can run the model analysis step by doing that. And with this, you kind of need the Jupyter widget. If you guys run through this within the Jupyter notebook, you should pretty much have the results, which I have it from my collab right here. This isn't the Penguin data set that we've previously covered. And you can, as you can see, you can kind of play around metrics, histogram, loss, sparse categorical accuracy. And you can see, what kind of features or species 0, 1, 2, and the losses and the accuracy regarding each feature, or, in this case, it's also the target variable, is the way how they define the, let me see, the evaluation. So they sliced it with the species or the target variable as the feature key. So both the label and feature are species. That's why you're seeing basically species here as well. Basically, we're just kind of dissecting, hey, what's the accuracy the model has on, one label and the other label and third label. So because I believe we have 3 species or 3 species of penguin in the data set. Okay, slices overview. This is example count. Sort of a slice. Yeah, so you can play around with this by load the evaluation results and render the slicing metrics. Then you can have that in your Jupyter notebook. And obviously, again, this doesn't go into the pipeline itself. It's just for your own, visualization purposes. But of course, you can always render this separately while you run through the pipeline and store, the evaluation artifacts somewhere and render it on a dashboard, so that you can always have this outputted as well. All right. Any questions on this? And this is how you kind of install the Jupyter extension to show that graph. At the time of writing Tfma, visualizations are not available in Jupyter Lab, only in Jupyter Notebook. Okay. Yeah, so for example, in this case, the data set has the overall as the feature, quote unquote feature. It's not really a feature, but binary accuracy is 76%, and you have false negative, false positive, true negative, example counts. And your AUC score is 66%. Or 0.66, your precision recall scores as well.
So this screen seems really interesting right here when you can do slices. So now if you're working with pretty large data sets and you want to get an intuitive sense for what's driving model performance, say you build a model and you just take that as it is to be something compelling. With slices, you can slice by, I presume, sort and slice the entire data set by, say, gender, male and female. For the credit scoring, if we were to do the difference between the different demographic categories or so on, to see how they score credit-wise, etc. Now, this is that kind of exploration is very useful in being able to tell a story around AI fairness and so on, but also just to get a better sense for what are you've built a model, but also using it to understand a little bit more about the data.
Yep.
Just my 2 cents.
Absolutely. And this, I'm sure this can be combined with feature importance and stuff as well, right? I think towards the end of the chapter, there is a section that talks about line and Shapley. Right. So yeah, so Shapley is basically based on game theory, and Lime is interpretable model agnostic explanation. So Lime is actually pretty cool. It's model agnostic, and Shapley seems to be so as well.
When it comes to, yeah, well, there's a little bit more there, if I may. Sorry, I apologize for interrupting.
No worries.
But when you think of explainable AI, there are different ways to look at one, of course, to explain a model's decision-making process. One is being model agnostic. When you're model agnostic, Shapley, Lime, as well as perturbation. And that's really exactly as it sounds. Like take the model and poke it a little bit, like change a few things, look at different slices, try to understand. That's the more model agnostic approach to try to explain what a model is doing. The other things, when it comes to explainable AI, those are model specific, like gradient descent, attention mechanisms. Those are specific to the model. And that's when you're playing with different hyperparameters. There are others such as integral models that we've done with basic machine learning, and some more very advanced stuff that involve neural representations that are actually beyond my ability right now. So this area of research is pretty broad and vast. But what they've got here looks very useful.
Yeah, absolutely. And this is the Shapley's GitHub or library. And as you can see, with this simple graph, this is your model up, and this is model outputs. And this is kind of, I guess this is the weight, this is probably the weights or disease prediction data set, most likely. You have the gender, BMI, that's the weight index. Am I correct? It has to do with weights. Your age, you're probably predicting probably disease, I don't know. But this is how you explain it, and how each of the feature is contributing to the model output. Yeah. Yeah. And with pretty interesting graph as well, and beautiful graph.
Theory for you. A lot of this, especially even in the chapter, he talks about counterfactuals and such. All of this comes from applied economics and econometrics.
Yeah. So what Shapley does is it gets all the possible subsets of features that don't contain a specific feature, let's say F, and compute the effect, meaning you get a lot of subsets of features that just don't have one single feature, and compute the effect on the model's predictions of adding F to all the subsets. So you're kind of seeing, hey, what's the effect of adding F to one subset, another subset, another subset. And eventually you kind of, I guess, calculate an aggregated score based on whatever mathematic formula that Shapley uses. Then you get the importance of feature F. So, so someone typed in the chat.
Yep, it's the white paper that explains the theory behind Shapley,
Cool.
and the different areas of the game theory that they have,
Nice.
in which they are trying to evaluate the explanations that our model presents, and how is it different from the system 1 and the system 2 type thinking of the popular book, Thinking Fast and Slow, I guess. Yeah. So,
Cool.
what kind of reasoning differences are there with respect to the biases and the causal relationships that we have? So, it's totally from a theoretical and uh, plus the implementational point of view too.
Cool. Very cool. All right. So,
And just FYI, here's the book that Mayank just mentioned, and the author, Danny Kahneman's release just today.
wow.
Awesome.
What's the noise book about?
It is, so when you think of thinking fast and slow, this has to do with a bias. Think of this as variance in noise, in just general ways of economic. Danny Kahneman is the father of behavioral economics. He's a psychologist, but that's what he won the Nobel for. And it's that general idea of this. And a lot of what we talk about with explainability in AI come from econometrics. And Google, Sergey and Larry long ago hired really, the economist who wrote the standard textbook, Hal Varian. Hal Varian is still at Google, and he helps shape a lot of the adoption of these economic ideas, advanced economic ideas, and built into what we're talking about. I mean, it's kind of why we have it sort of shaped the way this view has emerged. So it all, bottom line, we're touching on economics here, not just statistics or linear algebra.
Very cool. Cool. All right. Thank you, Mesh. And let's quickly look at Lime. Library. Seems like Lime is a little less popular than Shapley.
Lime is used more in R than Python.
Really, I've seen a lot of, I've seen people use Lime in Python as well.
Yeah, I've, for instance, used for machine learning, use both Lime and
yeah,
Shapley.
yeah. So we support explaining individual predictions for text classifier or classifiers that act on tables or images with a package called Lime, short for local interpretable model agnostic explanations. And here's a quick video. Why should I trust you? Explain predictions of any classifier. All right. Anyone has used both of these and knows the difference? I mean, when to use which?
Depends on the use case. So Lime gives you generic feature importance. Shapley is a lot more advanced. It's different. You'd have to refer to the documentation. You use, if it's just basic feature importance you want, and you can use, call it on most scikit-learn or even H2O, which gets you feature importance. That's really just Lime. Shapley is a little more complicated.
Yeah. Yeah. All right. Cool. Thank you. So those are some of the explanation tools that we could easily call from open source libraries. I guess, you could always just write customized codes within your pipeline. I mean, I guess not within the pipeline itself, but like pulling the statistics outputted or the files outputted from the pipeline while it's running through, and then visualize that, and also using customized or third-party libraries, open source libraries such as Lime to visualize your model evaluation on a separate dashboard. Okay. Great. So Mesh just shared a quick Medium article, idea behind Lime and SHAP, intuition behind ML interpretation models, local versus global interpretability. Very cool. Surrogate models. Right. I love those drawings and handwritings. Those are cool. Very handy. All right. I'm not going to spend too much time on this, but if you want to read more, feel free to go into this link and read this article. Thank you, Mesh.
maybe in a more hands-on class later on, we can try to build this with some of our data sets that you and I know well, and we'll try to build some of these things that you and I just texted about before the class, Wencheng.
Yeah, absolutely. Absolutely. So Mash and I are tackling a data set called for human resource. And we're also trying to wrap it around with a TFX pipeline. And that was our Friday night, last Friday. And that will be our Friday night, Saturday night, this coming Friday and Saturday. So
we are nerds.
Yeah. And perhaps, let's we can look at the schedule. Maybe there's something that we could add in, for the next, workshop, stuff like that. So cool.
So, you guys have hidden, or how do I say it, those private meetings too, to prepare for this?
Yeah.
Cool.
And we Wencheng and I collaborate on various projects outside of here.
Yes. We've been work buddies for a while.
Great.
Yeah.
If it's if you guys have space for one more, then I would be happy to jump in. If it's not too private or confidential, or in that lines.
Sure. We'll see if we can pull you in as time permits. We meet at crazy hours. Just a heads up, but we'll see what we can do. It would always be useful to have, one more minds, or maybe we can do one of these sessions, hands-on working sessions. Coming up, so everyone can, and you guys can see, like, when we build this, you're starting with, okay, here's the problem, here's the data set, we get it, let's start building a pipeline solution, and let's labor through something that's real world, and debug as you go along. It is that process of debugging, which I have to say, I admit Wencheng is infinitely better than I am, because he is a pro at Python.
Thank you.
A lot of times it really comes down to that. It's the raw Python programming experience that helps tremendously.
Yeah, it comes from, thank you, Mesh. It comes from a lot of nights and hours of debugging. It's just, and the more you do it, the better you become. That's just what it is down the road. And the easier you will be when you pick up the next tech stack. That's what I've realized in the past couple of years. I think the peak of my learning curve has passed, at least, and seems like it's been an easier process for me to write programs and learn new stuff. So, all right. So this is the fairness indicator. I have not got a chance to run this yet, and it seems like it basically tries to tackle some of the features that would deal with, AI fairness. Okay, and you would basically use it with TensorBoards. Okay, and you can output this to your eval results fairness, or actually in the fairness indicator logs. And you can output that as logs and load it up with TensorBoards. Okay. Accuracy. Different highlight. This highlights the variations from the overall metric value. And it shows more extreme differences between groups when the decision threshold is reduced to 0.25. So decision threshold is basically the probability threshold to determine your prediction for the classification label. Okay, then the book also talks about the what if tool. Again, this is more on the fairness side as well. And the book basically takes about 1,000 rows of data as a subset. And then you can use the widget and config builder. These would have to be downloaded as Jupyter extensions as well. And then you can show this as a graph, I guess it's interactive as well. And you can download these with Jupyter MB extension. Okay. All right. So we're going to basically talk more on these three components: the resolver, the evaluator, and the pusher. And these components will be basically incorporated into the TFX pipeline. The what-if tools, the fairness indicators, they're for your own monitoring purposes, EDA purposes, but they don't actually go into the pipeline itself. These three components do. So the resolver components is required if we want to compare a new model against a previous model. And we can use the latest blessed model resolver. It checks for the latest or the last blessed model and returns it as a baseline, so it can be passed on to the evaluator components with a new candidate model. So and if you don't want to validate your model against a threshold of some metric, then you don't have to run this component. Okay. If you don't validate the new model, it will automatically get pushed to the serving directory, even if its performance is worse than of the previous model. So this is how you define your model resolver with the resolver nodes. Again, this gets changed now with TFX 0.3.0. So I would be aware of this. If you want to play around with TFX 0.3.0, then you would have to change this code to tfx.dsl.resolver. 1 second. Let me pull up this code. Right here. So it will change to this tfx.dsl.resolver. Okay. And the evaluator component uses the Tfma library to evaluate models' predictions on the validation data sets. And it takes, it basically takes the model resolver's outputs as the baseline model, okay? And you would also need to set up the configuration like what we talked before. You can specify the label key and the feature key that you want to slice your model with. In this case, we're using the product feature or column as the feature key to slice our model. And you can run it again with context.run if you want to see the outputs, or just run one component by itself and passing the evaluation configuration right here with this parameter and pass the current model. So this is the baseline model. This is the current model from the trainer.outputs model. And this is the data set itself, example gen.outputs examples. And you have your path. You have your, this is how you get a path for your for where your pipeline saves the evaluation results, and you can load it up from that path, and then you can visualize it with this line of code. Okay, so this is where it gets very, very interesting. As you can set the threshold, say, hey, you know, this is the lower bounds of, let's say, my binary accuracy or AUC score. So and the change threshold is 0.01. So maybe the last model had performance of 0.65, and now I have 0.66. And then this model gets pushed and served, okay, because this is better, right? And you have to define the direction. Higher is better. You know, for accuracy, higher is better, right? And if it's 0.7, again, that's great. It will just get pushed, right? But if it's 0.655, then it doesn't, because it's lower than the change threshold. And what it does is the new model receives a blessing artifact. I don't know why they use such words, blessing or blessed model, but it's certainly an interesting way of describing a, I guess, improved model or accepted model.
It's on the under the analysis and validation in TFX. This TFX uses the concept of blessing to describe the gating process for deciding whether or not to deploy a model for serving. So it's just a gating process. It's in under the paragraph. If you try Control F and search for blessing, the first result, yeah,
Right here?
yeah.
Yes. So it uses the concept of blessing to describe the gating process for deciding whether or not to deploy a model for serving. Right. If a model improves the previous model based on the threshold we define, it is blessed and can move forward to the next step. Yeah. Great. Yeah, I was just curious why they use such words, or just maybe it could have been improved or accepted, whatever. Anyway, then if it's if it's blessed model, it gets pushed, right? If it's not blessed, it's not blessed. So what I've had is I had a model that was not blessed. Oops, I didn't have that ready yet. I guess I cleared that out. Let me try this. I have my eval config right here. I had the model trained. This is my trainer. Model run, logs. This is a saved model, my logs. My model run, okay, I don't have anything under here, but this is my model, saved model.pb, 9 megabytes. So I basically ran through all the components until like trainer, okay, and I've had trouble with evaluator components, but I'm gonna take out the model resolver and try it again. Okay, that's my evaluator. Context.run, evaluator. The baseline is missing because I guess I don't have a baseline model. This is the first time running it, or deleted the previously run models. So these are the errors that I'm getting. But however, this is an error that's also shown on TensorFlow tutorial as well. This is an error that I've been trying to debug a little bit, but most of the answers I've found is related to TensorFlow itself rather than TFX. So I've spent a little time today. I have not been able to solve this one yet. Okay. And let me see, TFX components. Yes, so it's still able to run with all the errors that it was outputting. And the error is called TensorFlow, this error. Oops. So even the TensorFlow's own tutorial has a bunch of errors, like 16 errors like this, all under trainer and also under evaluator as well. So for those of you, if you run through this and if you find an answer why this is happening, please let me know.
Yep, you can try raising an issue in the TFX repo. They uh, uh, the folks who work on this library may have encountered this before.
That's a good idea.
Yeah,
That's a fantastic
because
idea.
that's the only way to resolve these kinds of errors. I mean, I've have faced them earlier, and yeah,
Yeah, I will certainly do that.
mm,
I've let's see with TFX. TFX, get up. All right, I guess there are 200 people raised the issues.
yep.
So let's try to search a little bit. TFX.
There might be with respect to the recent changes in the point 3 version or with the
There you go.
with the Python. Yeah.
Someone had this error. All right, I'll look more into this. I can see the error starts. Assigned. This error has not been solved. All right, I'll raise it again with TFX, and I will keep you guys updated. Cool. Thank you, Mayank. That's a fantastic idea. I guess, when you deal with tech stacks that are relatively new, you kind of just have to work with the developers, instead of expecting all the answers from Stack Overflow. That's probably just how it works. All right. After we evaluate, then we push. Okay, and you can also get a validation check as well. Validation okay equals to true. Then you push it. Now this is pushing to the local file system. Okay, but if you look into well, let me pull up the books GitHub folder. You can see the pusher quarks right here. Okay, it takes the model from the evaluator, the blessed model, right? It has to be the blessed model. Okay, and but there is a conditional statement right here. If AI platform serving RX equals to true, then you import this AIP pusher executor, then you push it to your AI platform, basically. Okay, that's how you push it to your AI platform to host your model on your GCP instead of serving it on the local file system. Okay. And again, this is under base underscore pipeline.py. Okay. So, and next week, we're going to talk more about different serving options, different deployment options, and yep. Okay. And obviously, unless you're doing research, you don't really serve your model from your local desktop, or you don't really save your model on your local desktop. And you would try to push it to the AI platform itself. And I think I've showed this before on GCP, but next week we're gonna
Yep. This is from the repo, right? The repo that you have posted.
The practice pipeline. Yeah, the practice pipeline is, well, I have not pushed this code, but you can refer to the books repo as well. But books repo is under the pipeline folder.
Yep.
Yeah, base pipeline. Yep. So next week we might potentially do some Docker. Hopefully you guys have got some Docker tutorials going. Oops. Sorry. Let me. Okay, so let's look at the schedule. So we will be talking about model deployment with TensorFlow serving and advanced TensorFlow serving in next 2 weeks. And we'll talk a little bit about Docker, I guess, already in the next week session. And we'll talk about GCP. So hopefully make sure you have GCP registered. And then we can, use AI platform. And this is how you serve models on GCP, the AI platform. Let's look at Vertex to see if we have that. Oh, great, we have Vertex.
Yep, we have everything with respect to the Vertex here. It's here we have models in which we create the endpoints.
Mm-hmm.
Yep. We train the models here, and the endpoints is uh, the next. So the uh, code lab that I shared,
Yeah.
there are 5, and yeah, it's pretty much a straightforward.
Yeah, this is so cool. This it seems like it's way much more complete than AI platform. But I guess you could serve your model on AI platform or on Vertex. I don't know what the pricing is with Vertex AI. Is it more expensive than AI platform? It probably is. I don't know.
Yep, even I have no idea. Just the for training a simple model that took 15 minutes,
Okay.
and uh, uh, it had approximately $2 to $3. That so
Okay. Training price per node hour, classification object detection. We're talking about tablet data. Price per node hour. Damn, that is expensive. That's pretty expensive. That's $20 an hour. If you train for 10 hours, that's $200.
yeah.
Yeah, it's pretty expensive stuff. Image data is lower pricing. Yeah. But I guess if you train locally and just serve, deploy that, and just use that as only for inference, then that's way cheaper. $1 per batch prediction per hour. That's a lot better, right? And so I mean, if it's not like crazy model, then I would train it on your laptop. So yeah, let's look at AI model and model platform pricing.
Preferences, cost,
Basic,
index,
standard, and down machine types.
spelling.
That's price per hour. Yeah, that looks a lot better. Yeah, instead of $20 an hour. Oh my god. Yeah. And TPUs, you have GPUs. GPUs 83 cents, right? 83 cents training units per hour. That's not bad.
Oh.
Yeah. So I guess AI platform is still, an option for, training. If you're concerned about pricing stuff, but Vertex AI certainly is the way to go. It seems like for ML ops platform. Yeah.
Yep. It's I have just viewed my billing. Um, it's
Yeah.
just point 0.4 rupee, so it's not even a single rupee for the. I think so. I played around with it for an hour or so.
Mm-hmm.
I share my screen.
Yep. Go ahead.
So if you can see here, yeah, this was the training and the stuff that I did last night. So it's training unit for us on the AI platform or Vertex AI. I think so. Uh, uh, there's a how do I say it? So it's just point 0.4 rupee. That's not a dollar too. It's very very
Yeah,
hard.
yeah,
Yeah, that's less than a nickel.
Yep.
right, right. That's great. Cool. All right. So next week, I'm also switching a laptop. So I just got the laptop with M1 chip. So I'll certainly be trying that as well. And hopefully we'll demo a little bit, see what the performance is like for the M1 chip.
But there are issues with respect to the optimizations at the low level. Still, yep.
Okay.
You have to be careful there because it's quite new, and I was checking out the repo that the branch that they have with
Yeah.
the TensorFlow M1, the optimizations that they are trying to make.
Yeah.
Uh, there are some issues, but I think so. The upper level things will work fine with respect to TensorFlow. I'm not too sure about the TFX and stuff uh, because the issues that you are currently facing here, they might be extended there too.
Hmm.
Yeah, but that's just a guess.
Okay. Okay. All right. Well, I'll certainly be trying it out. I'm still configuring and setting up the laptop, and I'm already liking it. It's actually not that pricey. I mean, I pretty much spent the same price 3.5 years ago. I was getting a 128 gigabytes, and now I'm getting 1 terabyte uh, with M1 chip, and this is with 8 core CPU and 8 core GPU,
Yep,
and
yep.
16 gigabytes of neural engine memory as well. So like, I mean, I gotta try it out. It's seems like it's pretty cool. So I'll certainly keep you guys posted next week, and doing some training on my new laptop. That'll be exciting. All right. Well, on that note, that's today's session. We'll definitely, so next week, we'll basically be talking more about serving and deployment. That's pretty exciting stuff. Then you can push your model right to the platform where basically then everyone can call your model wherever, right, with the link and an API link. So yeah, pretty exciting stuff. All right. And any other questions before we close?
Will you push the code that you have showed?
I'll probably try to push it tomorrow.
Okay.
Yeah, it's pretty late now, and I'm still trying to debug a little bit. Hopefully
Uh-huh.
tomorrow I'll push it to the GitHub. Yeah.
It's fine. And you can push it with the error too, because it might take a while if it's the graph stuff that I think so. That's the issue
Yeah.
here.
Yeah. Yeah.
Yeah.
All right. All right. I'll certainly do that, Mayank. Thank you. And we'll let you know, Mesh, and we can talk about if maybe you can join us on Friday or Saturday whenever you're available, Mayank, because I know you don't sleep.
Yep.
Yeah, and a very good morning to you, Mike. The birds
All right.
are out.
Yeah. All right. Have a good night, guys. Bye.
Great job, Wenchang. Thanks,
Yeah.
Mike, and stay safe, everyone.